What's that?
What are you doing a session on?
Cross security with
Is it NSX
vSphere,
stuff?
and then yeah, we're gonna get
There's
there.
a bunch of NSX swag.
Oh,
give
okay.
away.
Giveaway. All right.
Yeah.
Thanks, Chris. Okay. Ready to go?
Yep. I'm just going to try to these cables a little bit.
Okay. Good morning. Welcome to VMworld and welcome to our presentation on multi-layer security in the software-defined data center. I had a question a few minutes ago about whether we were going to cover NSX, and you can't really say, I don't know that I'd use the word cover when you're talking about a 30-minute presentation, but about half of what we're going to talk about is NSX. But this is going to be security as applies to vSphere 6.5 and NSX 6.3. As the malware developers get better at their job, we have to get better at our job. We have to protect our data from a dozen different directions now. 15 years ago, I taught. By the way, my name is Kirk Lacewell, and I'm a senior technical trainer at VMware. 15 years ago, I taught security classes, and back in those days, security meant the firewall at the perimeter of the data center, and maybe 2 firewalls and a DMZ and some bastion host in there. Oh yeah, and don't use your pet's name as your password. That was really what we talked about for 5 days in that time. Malware developers have gotten a lot better now. They can get malware into your environment from a lot of different directions, not just through your perimeter firewall. And at the same time, VMware is at the spear's tip of the push for people to move their data out to the cloud. We're partnered with Amazon now, and we're pushing in all directions to move data out to the cloud. Well, that's a scary thing for people, because if you can imagine being a security manager at a big enterprise where somebody tells you, now we're going to move our data out to the cloud. You got to protect in a lot of different ways. So now this was originally put together as an hour-long presentation. So we're going to go very briefly through the security features of vCenter. We only have 3 slides on that anyway. And there hasn't been a lot changed in that in the newest generation. But then we're going to cover security features for the ESXi host, security features at virtual machines, and security features with NSX. So one of the key things that came about with vSphere 6.0 and carried over to 6.5, of course, it relates to security, is our ability to manage certificates in a much more articulate way than we could before. We issue our own certificates, but then we can publish, or we can store and publish to our users certificates from other certificate authorities as well. We can use Active Directory, and we get all the security of Active Directory and Kerberos. As I said, we're going to go briefly through these slides about vCenter. And of course, the distributed switch hasn't changed much in this most recent generation, but there are a lot of security features about that allow you to keep traffic separate. Something that is new is this multiple TCP/IP stacks, and you can have a separate TCP/IP stack for vMotion, for VXLAN, and you can create custom TCP/IP stacks for other things, which means you can have on a single interface, you can have dual sets of IP addresses, including default gateways and things. So the ESXi host, this is something we've been able to do for a while, this lockdown mode, but we've added this new feature called strict lockdown mode. Typically in today's world, you're going to manage the ESXi host through the vSphere web client. This prevents any user, or through vCenter and the vSphere web client, this prevents any user from connecting directly to the ESXi host. So it just cuts off that path of attack. We have 2 lockdown modes. The DCUI stands for Direct Console User Interface. If you've seen a ESXi host, that's the yellow screen that you'll see if you if you either connect to it through an ILO or a DRAC, or you actually go into the server room and stand in front of your host. And then with normal lockdown mode, only users on our exception list can access it. With strict lockdown mode, it's actually the DCUI is stopped. And then we'll have a list. If you ever use strict lockdown mode, make sure that you configure a DCUI.access list. Those are the users who can bypass that and start the DCUI. In fact, if you were to enable strict lockdown mode without that list, the first time you had to manage your host, you would have to reinstall. So it's pretty drastic. We support dual mode authentication now and smart card authentication. Probably some of you have smart cards where you work, where you have to keep the card right in the slot on your keyboard or your desktop to access. So we support that directly now. User are then prompted for the smart card and PIN, and as well as their password. If you're familiar with earlier versions of vCenter, you know that every action was logged as if a user called VPX user had done it. You'll see on that top part of the slide. What actually occurred was vCenter would connect to your ESXi host as VPX user. You would log into vCenter with your login credentials, and any commands would be converted to this VPX user. Well, that left us unable to track who had done things in the log. Now, we would see that a virtual machine was created or deleted or modified, but we could only see that VPX user had done it. Now, and that really left us out with logging. As of vSphere 6, we added the feature that it shows who's actually creating that action. So you'll see in the bottom it shows somebody called corp/administrator did that. We support UEFI boot. That's Unified Extensible Firmware Interface. And what that does is creates a hash value for the boot sector when the system's installed, and checks that hash value at boot up every time using a digital certificate, so that we can tell if the boot sector has been changed. This is getting rather common in the high-end or in the newer laptops and desktops you'll buy on physical machines. Will support this as well. It's a much quicker boot, but from a security point of view, it allows us to know if something has changed. So one of the big attacks that can occur from malware developers is that they'll apply some software to a machine that doesn't attack it immediately, but edits the boot sector so that the next time it boots up, it'll be under attack. Well, this will prevent that. We support that and we go through the process here. Boot sequence first starts, the hardware validates, the UEFI firmware validates the bootloader to make sure the certificate matches and the hash value is the same. If it passes the sequence, entire system is booted with a root of trust certificates. So it associates that root of trust with the certificates so that we know for sure that we're booting with a clean system. And that's UEFI as relates to the ESXi host itself. Of course, the ESXi host is the one that runs the virtual machines and provides power to them. So now we're moving on to virtual machines, and you notice the first slide is very similar to the last one. So we support the UEFI boot with virtual machines as well. The virtual machine has to support it. It's a much faster boot process than the earlier BIOS boot that we've used for probably 20 years or something. Much faster boot. It's only supported if the operating system supports it and the hardware supports it. And so you have to use hardware version 13. Hardware version 13 is what came into being when we at vSphere 6.5. So this is brand new to vSphere 6.5. You'll configure it in the settings for the virtual machine. So you notice on the top red box there we show select an EFI boot, and then on the lower box we check in the button for boot this using EFI. Another new feature with 6.5 is virtual machine encryption. Virtual machine encryption, and of course we're getting back to what I said in the beginning. We're expecting people to push their loads out to the cloud now, and trust them to be managed and to be run by some other entity. Well, this is a way we can protect them, and maybe a way we can convince IT managers that this is a logical thing to do. So we'll encrypt the virtual machine. It's based on key management protocol, implementation protocol. So you'll have to have a KMS, a key management server, and we have a new access control level. We've had all along administrator. We still have administrator that has full rights, but we have another access control we'll see on the next slide that allows for management of the virtual machines without management of encryption. The encryption doesn't require any in-guest agents. In the early vSphere and virtual infrastructure environment, in the past years, we used to support guest agents in a lot of cases. We're in general getting away from guest agents altogether because they add a workload to the guests. You have to install an agent on each guest. You have to manage an agent on each guest. Uniform methodology across all operating systems. So because we do this down at the hardware level, we don't. It doesn't matter to us what operating system is in that virtual machine. We're down below the operating system, so there's no difference. Any virtual machine can be encrypted, and it's done the same. We can manage we encrypt the virtual. We encrypt all the files that comprise a virtual machine, and you can encrypt them using different keys for each file. By default, vCenter Administrator has cryptographic privileges, as I mentioned before. We have a new administrator role now that we refer to as No Cryptography Administrator, which means that user can do administrative tasks except that relate to cryptography. In any enterprise environment in today's world, you're going to have separate technical groups that manage separate aspects, and one of the aspects we're going to manage is security. So we can give this right to the security administrators and not to the virtual machine administrators. And here's the list. It's a graphic that shows us a list of rights: manage encryption policies, encrypt new, manage KMS, the key management server. So all the different aspects, add a disk, clone a disk, decrypt, are broken off so that they can be addressed by that specific user. Including console access for encrypted virtual machines. Now with vSphere 6.5, we support encrypted vMotion. And again, if you think about the cloud, if you're moving data within the cloud or from cloud to cloud, where that data is passing entities that we may not trust. And previously in vMotion it was in plain text, or it was unencrypted. So now we can encrypt vMotion. It includes a migration spec, an encryption key, and a nonce. A nonce is a single-use encryption value. I thought it was a typo when I first saw that. I had to Google that word, nonce. With encrypted vMotion, the requirement is that you have vSphere 6.5 at both ends. Then you have three settings. There's either required, opportunistic, or disabled. Required means don't do a vMotion if you can't encrypt it. Opportunistic means try to encrypt it if you can. If you can't, do it unencrypted. And of course, disabled means we're not going to do encrypted vMotion. And then something that we have a slide on, but this is not new, but it's still a critical feature, is the ESXi firewall. So because the ESXi firewall is running your workloads, you have to protect the ESXi host itself from attack. But we've had this for a long time. And now we're moving into NSX. I know that a lot of you came here to hear about NSX. And that's my specialty. That's what I teach for VMware, and I teach NSX almost every week now. NSX is a multifaceted platform for networking and security. And my understanding is that we talked about NSX as network virtualization in the beginning, which it is that. But my understanding is that we have as many customers for NSX that are buying it simply for the security features. Because as I said earlier, it used to be good enough to protect from attack through the perimeter firewall. And that's not true anymore at all. Now we need to protect inside. We need to protect each of your VMs from each of your other VMs. So if you notice in the green here, there's built-in services. We have NSX Edge Firewall. That's our equivalent of the perimeter firewall. Typically that would be inside of a physical firewall. So you'd have a physical firewall, then you'd have your DMZ, then you'd have our Edge Firewall. And we have this other one, the distributed firewall. The distributed firewall is a whole new concept altogether. And when you configure the distributed firewall, you come to have an instance of the firewall associated with each virtual machine individually. If you think about it, that kind of points back to what I think, like in Windows 2000 days, Microsoft and other server vendors started having those in-operating system firewalls, but they're a lot hard to manage, and the larger your environment got, the more difficult it got to be to manage. The distributed firewall we can manage based on what we call virtualization context awareness. So we can have firewall rules that apply to every virtual machine running on a particular host, or attached to a particular switch, or with the letter WEB in its name, or with Windows in its operating system name. It's really versatile. We can do that in a lot of different directions. Over in the yellow side there, third-party services, we can use NSX to redirect traffic through our partners' third-party services. You can see those guys all over in the solutions hall. You see all the vendors over there that create things that run in conjunction with our vSphere environment. Well, that's how we support those. Redirect traffic through a layer 7 firewall, or antivirus, or DLP, vulnerability management. And we even have some built-in vulnerability management with vSphere 6. With NSX 6.3, we have something called Endpoint Monitor that will manage your, is that a fly? that will manage your, monitor your machines to look for services running, for instance. You've all heard of that WannaCry, for instance? That's a service with a specific name, MSS VSC 2.0. And so we can find that, and we can create rules that will then automatically come into place that will protect the other virtual machines from that virtual machine. So it's not just protection at the perimeter. And here's with the graphic of what I've been talking about. So there's protection, in the olden days, we had protection at the perimeter, and it says insufficient. Well, it was sufficient for a long time. And that's all we talked about in the classes 15 years ago, in security classes. Now, you hear about attacks after attacks where something gets into a data center, some non-standard way, through an email, through being embedded in a layer 7 application. Somebody sneaks it in through a flash drive, maybe inadvertently, and then that will attack. That's how WannaCry works. It'll install itself on a single entity, a single VM in the data center, and it'll attack on port 445, everything in its Class C subnet, one by one. It will 10 at a time it'll hit. And that's where this kind of firewall comes into place. And this is our graphic of the firewall. So you have the fellow over there at the cloud management platform. He's creating firewall. He's creating virtual machines. And as part of the virtual machine creation process, he creates a security policy. Now, he doesn't necessarily need to do that at the same time. It could be that you're the security manager and you create a policy that says, for every virtual machine that has Windows in its operating system name, set this set of rules. Then I come along the next day, maybe I'm the guy at the console there, and create a new Windows machine. Well, my Windows machine is automatically protected by your rules without either of us interacting at all. And then he deploys the virtual machine, the firewall goes with it. Later he vMotions the virtual machine, and the firewall follows it to its new location. So that's protected even if it moves. And of course, that's another thing. 15 years ago, there was no such thing as vMotion. 15 years ago, if you had asked me if someday somebody was going to invent a way to move a running host, a running server from one place to another with no downtime, I'd have laughed at you. Yeah. Well, VMware engineers do a lot of things that I'd have laughed at you for suggesting 15 years ago. It's amazing what those guys can come up with. But anyway, so the firewall follows it, and it's always protected, stays protected. Here's an example of firewalling. On the left is firewalling without NSX. And the key here is that we have two VMs in the same data center, or in the same rack probably, that are on different subnets. They need to get routed between subnets, and they need to be firewalled. So for that to happen, you'd have to come all the way through the top of rack switches, through the fabric, up to the core layer, get firewalled and routed, and then return the same way. We call that hairpinning. Hairpinning is the concept of moving out and back in on the same, or passing the same path twice in a single communication. And it's obvious that that's not the way to do it. It's a waste, and because there's all these clock cycles are happening. Every step is multiple clock cycles, so it's a long time for that to happen in computer terms. If you look at the right-hand side there, that's an example of using NSX. We have something called a distributed logical router that exists on all the hosts, and any network that touches that host can route inside the host. So right inside the same host, they're routed. And you notice we have two firewalls, one firewall for each virtual machine. The distributed firewall is everywhere. So every virtual machine has its own instance of the distributed firewall, and we have much less traffic involved here. This is really the same slide, but using different hosts. And you'll notice that since the virtual machines are on different hosts, we are going to have to get out to the hardware networking layer, to the top of rack switch. But we don't have to go anything beyond that to get routed. So in this case, it cuts the path down drastically as well. The NSX edge firewall is what we use to protect north-southbound traffic, or actually southbound traffic coming into the data center. The distributed firewall, the little firewalls you see on every VM there, are part of the kernel, the vSphere kernel, and they're there to protect against attacks based on east-west traffic. East-west traffic is traffic within the data center, between VMs in the data center, or between entities inside your data center. And north-south traffic is traffic leaving the data center or entering the data center from the outside. The edge gateway, we actually call this device the Edge Services Gateway. And the reason we have the word services in there is because it has an extensive array of services that it supports. And because of that, and it's deployed as a virtual machine, The distributed firewall that we mentioned before is not a virtual machine. It's embedded in the kernel. The distributed logical router is not a virtual machine. It's embedded in the kernel. The edge gateway is a virtual machine, and it comes in 4 sizes. By default, it'll deploy as a compact size with one CPU, one virtual CPU, and half a gig of RAM. But then, as your workload goes up, you can convert it to higher. Or if you know you're going to have a heavy workload to start with, you can have a larger one when you deploy it. And you notice it's dependent on what kind of workload you have. So, and you can do that on the fly. You can just highlight the edge gateway, click actions, and and you'll have one of your selections is change appliance size, and you'll be able to do that. Distributed firewall provides, so the distributed firewall we've been talking about optimizes traffic, prevents hairpins, provides distributed enforcement of policy rules, throughput scales as hypervisors are added. So because it's part of the hypervisor and not a separate entity, not a virtual machine running in the hypervisor, you don't have to deploy a virtual machine on each host. It just takes a certain percentage of the power of the hypervisor. Provides centralized configuration using the vSphere web client. And to me, that's the thing that differentiates the distributed firewall more than anything else from the in-host firewalls that I mentioned earlier, is the fact that you can manage it so much more efficiently. You can have rules that morph as time goes on. Like I said, you can have a rule that when endpoint monitor sees WannaCry or anything else running in a VM, it can propagate a firewall rule automatically into the distributed firewall that quarantines that VM or cuts off all network communication to the VM. And then you can have rules beyond that that'll do whatever you need to do with it. Use antivirus to clean it out, destroy it and replace it, So we address security from a lot of different directions. The firewall rules can be based on operating system. So we have a component called Service Composer that allows you to create policies that apply to virtual machines, create groups of virtual machines that the policies apply to, and associate the two. And the groups can be based on operating system. As I mentioned, anything with Linux in its operating system name, but that's the name that's inside the operating system. We can read that through VMware tools. Or Windows in its operating system name, or 2012 in its operating system name. The virtual machine name, if you have a strict naming convention, anything with web in its name, or anything with app in its name, or SQL in its name, the services that are running, that's where our versatility comes from with the distributed firewall. It's the ability to make these rules that apply or don't apply based on what the system finds. So it got back to my example of me coming along the next day and creating a Windows machine, and it's automatically protected, and I don't have to worry about it. When you create the groups, we can use dynamic inclusion, which would be based on the name or some characteristic of the virtual machine. So for instance, you could have, say, any virtual machine with Windows in its operating system name as part of this group. And then let's say you have 50 Windows servers, but 4 of them are domain controllers, and you want to treat them differently. You could have a static exclusion that where you listed each of the 4 domain controllers, and they wouldn't be affected by these rules, or they'd be affected by a different set of rules. And the rules come together in policies. You create a group of virtual machines, you create policies that point to that group of virtual machines, and that's how they get associated. And that's in our feature called Service Composer. And here's some policy rules. You can create firewall rules, so you can manage the firewall directly, or you can create rules through Service Composer that manage the firewall. You can have endpoint monitor detect things that you want to protect against, and then endpoint monitoring in association with application manager would automatically edit your policies in Service Composer and push those rules there. So you can have, if an attack occurs at night when everybody's home asleep, you can respond to it. You can have your system respond to it right away by taking that VM out of service or whatever needs to be done. And then the way we would respond to it is that we could run antivirus against the machines. This is a concept of tags that we have here, where when we run antivirus, if we find a virus or a malware, we put a tag on it, and then we have another rule that says any machine with a tag on it gets quarantined, which means disconnected from the network. And then cleaned out of whatever rules you want to have happen after that. So. Any questions about security with vSphere 6.5 or NSX 6.3? Excuse me? RSA, what's the question? Yes, it is, yes. Yes, it is. RSA is a two-factor authentication, yeah. Thanks for coming. Hey, I've got a bag of NSX things here. I don't know what's in it because I was just presented with this bag of NSX things. Anybody want an NSX thing? Seems like there's a t-shirt in here and a book for dummies. You don't have to be a dummy. You know, it looks like, I don't know how many I have here, but blue one? Okay, blue's your favorite color.